Hello again, fifth grade. We're ready to move along to lesson 83. So last time we talked about work, so we're going to talk about ways to make work easier now. So we're going to talk about machines, simple machines, and specifically inclined planes for this lesson. So go ahead and open to page 3. Remember, work is the transfer of energy from one object to another in order to make the second object move. And the force that acts on it is the effort, and the object moved is called the load. So if nothing moves, no work is being done. And then we calculate that by work equals force times distance. And the unit that we use to measure work is called a joule. And then we also talked about slides and rollers and how those make it easier to carry a load. Okay, so we're on to page 4, and we're going to talk about machines. So paragraph 1. A machine is a device that applies force or changes a force in order to do work. A machine makes work easier by changing the strength of a force, the direction of a force, or the distance through which a force is applied. Machines make work easier, but they do not change the amount of work being done. Okay, that's important to keep in mind. So even though it feels like it's less work, there's still the same amount of work being done. It just makes it easier to do. Okay? So a machine, device that applies force or changes it in order to do the work. So at the beginning of the first sentence, highlight the word machine. Remember, it's going to change the strength of a force, so it can apply a stronger force, the direction it's going, or the distance. Okay, machines can make work easier by increasing either force or distance, or changing the direction of a force. No machine can increase both force and distance. It's like we said, the same amount of work is being done. Remember, work is force times distance. So you can't increase the force and increase the distance and still have the same amount of work. You can only increase one, and it's going to decrease the other so that the work still equals the same. So let's say you started with 1 Newton of force, 1 meter of distance, 1 joule of work. Okay? And then I'm going to increase, okay? That's a bad example. Let me give an easier example. So let's say 5 newtons of force, and what would be 1 times 5? Let's say, kind of give an easier one, 5 times 15, let's say. So 5 times 15 is going to be 65. I just did it a hard one again. Let me think of an easier one. Let's do, what's an easier one? I'm trying to think of one. How about 7 times 4 to 28? Okay, that'll be an easier one to explain. So 7 newtons, 4 meters is going to be 28 joules of work. Okay, and then I'm going to change it to 12 newtons of force. Okay, so now I'm increasing the force. The distance is going to decrease. Okay, because if I use more strength, that object isn't going to have to move as far for the same amount of work being done. So if I have 14, I said 28, didn't I? 14 times 2 meters, it's going to be less distance but more strength. I know I probably just confused you even more. But basically, you have to still end up with the same number. So it's kind of like those factors that we talked about in math. Your work is going to be the same. So that end number remains the same. You're either increasing the strength, decreasing the distance, or you're increasing the distance and decreasing the force. Okay, it's still going to balance out. Sorry if I confused you even more. Okay, so paragraph 2, we're going to talk about most basic machines. The most basic machines are called simple machines, and you've been learning about these since probably 2nd grade. The 6 simple machines are the inclined plane, screw, wedge, lever, pulley, and wheel and axle. A combination of 2 or more simple machines connected and operating together is called a compound machine. Okay, let me pause for just a second. Okay, sorry about that. So, simple machines. So go ahead and at the end of the first sentence, highlight the words simple machines. You should have learned about those before. I know you did in 3rd grade. So 6 simple machines: inclined plane, screw, wedge, lever, pulley, wheel, and axle. And we're going to get into detail on each one. And today we're mainly going to focus on the inclined plane, which is the most simple one. Okay, so if you're taking 2 or more of those simple machines and putting them together, that's where you get a compound machine. Just like a compound sentence is 2 sentences put together, a compound machine is 2 machines put together. Okay, so at the end of the last sentence, highlight the words compound machine. Okay, now for the middle of page 4, you'll see it has a new title saying Simple Machine Inclined Plane. So we're going to get into more detail with the inclined plane. Paragraph 1. An inclined plane is a sloped, flat surface that is used to raise a load. A ramp is an example of an inclined plane. An inclined plane is a simple machine that reduces the amount of effort needed to raise a load, but increases the distance the effort moves the load. Okay? So it's reducing the amount of effort, but increasing the distance. Remember, you can't increase both, you can't decrease both. One goes up and one is going down to equal the same amount of work. Okay, so if you think about a ramp, if you take a ramp to get up to a building, it's going to take you a lot longer than if you're just going up the stairs, because it has to increase the distance in order to decrease the effort that it takes to go up it. It takes more effort to take the stairs. Okay, so at the beginning of the first sentence, highlight the words inclined plane. Okay. So like we said, inclined plane, it's going to reduce the amount of effort by increasing the distance, because that long flat surface is going to be a longer distance than if you're just going up the stairs. So there is a chart, and here's another experiment that we would have done. Basically, we would have created some inclined planes. We would have stacked up some books and then had a little race car go down an inclined plane. And you would have measured how much effort it's going to take for that car to move. Okay, if you increase the distance, you don't have to push as hard than if you have less distance. If that makes sense. Okay, so you would have stacked the books, then the inclined plane, and measured the amount of work being done. And that's something you could do at home too. It's pretty easy to make an inclined plane. You just need a long board or something like that. You could even take a book. You can make an inclined plane out of 2 textbooks if you want. If you want to put one textbook flat and then prop the other one up and then make a car roll down or roll a ball down it and see how much effort that takes, and then put something longer on there and see how much effort it takes to push that one. Okay, that'll give you an example of why we use inclined planes. Okay, and we're not going to fill out the chart because we're not able to do the experiment. And then you would have been able to use a spring scale to measure how much force is being done. So you would have been pulling stuff up the inclined plane. That's the thing, because going down the inclined plane is going to be more to do with gravity, whereas pulling something up the inclined plane, measuring how much work that is being done, is going to be different. Okay, if something is a steep inclined plane, it's going to be much more effort than if it's a more flat of an inclined plane. Think about, hiking up a mountain. If it's a really tall mountain, it's going to be hard to hike up than if it's just a sloped hill. Okay, it takes you more effort to go up the steep mountain. Okay, and there's only a little sentence below that chart. Let me see what this chart looks like. So we can't measure the distances and that kind of stuff, but basically what you would have found is the method of raising the load that requires the least effort is a longer inclined plane, like we talked about. It requires the most effort if you just lift something up vertically, because that's a steep slope if it's going straight up. If it's more flat, it's going to take less effort. Okay, so it says which way of raising the load moves it the longest distance. It's going to be the longer inclined plane. And if it's a short distance, it's just going to go up vertically. Okay, it's going to take a lot of effort. So if you think about going up that ramp like we talked about, it's going to take a lot less effort than going up the stairs. Okay, going up an elevator, you have even less effort or even less distance happening, but that elevator requires a lot of effort to lift something straight up. That's why it's got so many moving parts to it. So below that chart, there's one more sentence. It says a longer inclined plane requires blank effort to raise a load than an inclined plane that is shorter, but the load moves a blank distance. So we're going to fill in those blanks. So on the first line, what do you think it might be? A longer inclined plane requires more or less effort. If it's longer, you have more distance, it's going to be less effort. So write less in the blank if you have it printed out. You could type it in there too if you have it digitally to where you could type on there. So it's going to be less effort. You should be able to open it in Google Docs too, now that I'm thinking about it. You can open up a PDF in Google Docs and then you can type directly onto that and you can highlight it that way too. So that's another option you have. Okay, so that's the first blank. It's less effort because you have more distance, right? But the load moves a blank distance, a shorter or longer distance, that longer inclined plane. Okay, if the inclined plane is shorter, it's going to be a longer distance. Okay, so the first blank was less effort, longer distance. And you'll find if you have more effort, it's a shorter distance. Okay, like I said, it all balances out. One goes up, the other goes down. Okay, and that's it about the inclined plane. That's a pretty easy one to learn about. It's like ramps and stuff like that, or a board. So that's a pretty easy, simple machine. So next time we're going to get into a few of the other ones, wedges, screws, and wheels and axles. So like I said, this should be pretty review for you, but we're going to get a little more in depth into some of them, to some things that you might not have thought about. Okay, so I'm going to go ahead and post the lesson review 83. So after you watch this, go ahead and do that lesson review.